Hi guys, we are going to do lesson 7-4. You will need your bell ringer sheet and your textbook. Now if you don't have a textbook, let me know or let Miss Turner know and we'll be glad to get you one. Alright, let's begin with our bell ringer. It says that the diameter of a circle is 40 centimeters. What is the radius of the circle? Okay, well before we start this, I want you to go ahead and take a note. You need to understand that a diameter is a line that goes from one edge of a circle to the other edge, just like I drew there for you. And I'm going to just put the letter D here to represent diameter. And a radius, my circles, bless their heart. Okay, a radius starts at the center of the circle and runs to one edge. And I will label this with an R for radius. Okay, so now that you have a visual of the two, maybe you can figure this out on your own, right? Of course. Well, if the diameter is from edge to edge and you just need to know half of that line, can we not take this number 40 and divide it by 2 to get that half we need? What would our answer be? Hopefully you said 20, and you are correct. So if the diameter of a circle is 40, then your radius would be 20. All right, here are your two vocabulary words for this section. Now, I asked you to turn to page 376, right? But if you flip back to page 374, you might see both of these labeled there for you, highlighted in yellow. So make sure you go ahead and star those. But a probability model, guys, it consists of two things, and these are very important. Make sure you really focus in on these or you won't know what to do when it asks you to describe a probability model. So a probability model consists of sample space, and I will show you what that means in just a moment. Also, it consists of events within that sample space and their probabilities. Make sure you remember that an event is just an outcome. So if we roll a dice, what is that outcome? Okay, second term, sample space. That is just the possible outcomes you could get. For instance, if we roll a dice, you know we can get outcomes such as 1/6 for the probability of a 4 or 3/6 for the probability of an even number on that dice. So outcomes are just your results. Okay, on here, this is just giving you an example of what your whole lesson is going to be about. So if you want to read over this, you can. I'm just going to go ahead and push forward. Let's begin now on page 376 with that first problem, guys. Number 4, develop a probability model for the spinner shown. Well, go back to your vocab. What is a probability model? That's important. If you don't know that, we can't answer this, right? A probability model consists of two things. The first thing I told you was that sample space, right? Okay, now the sample space is just exactly what you see. What do you see on the spinner? You will see sample space in these weird little brackets like this, if you wonder why I'm drawing them. Okay, hopefully you saw on that spinner a 1, a 2, a 3, a 4, and a 5. So for our sample space, our answers, 1, 2, 3, 4, and 5. Okay, the second thing we must have is their probabilities. So I'm just going to abbreviate that with the word PROB. And again, that stands for probabilities. Well, how many numbers did you count on that spinner? You counted 5, so we need 5 different probabilities. So here we go. This should be easy. What's the probability of spinning and landing on 1? What is the probability of spinning and landing on 2? Probability of spinning, landing on 3. Probability of spinning, landing on 4. and the probability of spinning and landing on 5. Now, guys, you should be able to do this by yourself. Hopefully, you'll press pause and try this on your own now. All right, check those answers with me. Hopefully, you got them right. And yes, they're all the same because this was a fair spinner. Let's move on to number 5. Number 5. Mr. Henry has a basket full of fruit. He does not know how many pieces of fruit are in each basket or the types of fruit. Each of the 20 students in his class selects one piece of fruit from the basket without looking, notes its fruit type, and then places it back in the basket. Based on these results shown in the table, what can the students conclude about the probability of selecting an apple? Okay, so the first thing that we're going to want to do here is determine how many apples were placed in that basket. Here on the chart, you can see that there were 5 apples placed in the basket. So my numerator will be 5. Okay? Now, we need to make sure you understand how to get the denominator. I do not want you to get confused with this number here that's referring to the number of students. Right now, you're looking for the probability of an apple. Well, there are 5 apples out of how many pieces of fruit? So this is really irrelevant for your proportion here. We would need to add all of our fruit up to get our denominator, which would give us 20. That would simplify to a fraction of 1/4. And then that, you could type in your calculator now and get a percent. Remember, just take your fraction, 1 / 4 times 100, gets you a percent. That final answer would be 25%. But make sure we answer this question with a sentence. It states, based on the results in the table, what can the students conclude about the probability of selecting an apple? All right, so the students can conclude that 25% of apples were picked from the basket. All right, the probability model based on an experimental probability for randomly selecting a marble from a bag is probability of green, 18/40, probability of blue, 14/40, and probability of white, 8/40. About how many marbles of each color are in the bag if there are 60 total marbles? Okay, this one is kind of tough, guys. Just bear with me. Let's begin by writing the green part down first. For the green, all right, number 6 here, I want to ask you to go ahead and put the word skip on this one. Don't mark it out because we may come back to it later. But for right now, we're going to skip number 6. Murray spins the pointer of the spinner shown at the right. What is the sample space for the probability model? Okay, remember, sample space is what you see when you look at that spinner. So I'm going to go ahead and write my sample space, which would be my A, Y, 3, 5, A, and so on. Okay, notice this S here stands for sample space, and you will see the sample space being put into those little brackets that I struggle drawing with. So just make sure you're familiar seeing the letters inside these brackets along with this S here, which stands for sample space. Next, part B, what is the probability of each event in the sample space? Well, what did you write down in the bracket? You wrote down an A, a Y, a 3, and a 5. So you need to find the probability of all 4 of those. All right, here are your probabilities for each of your sample space. Of course, you noticed all of these are 1/4, right? Very good. All right, number 8. Raphael spins the pointers of the 2 spinners shown at the right. Find the probability of each possible sum. Okay? Okay, I don't want this one to become confusing, so let me use some color coding here to help you out. So within this table you see here, this is actually representing both of these spinners, but I need you to be able to understand what spinner's what, right? So let me help out here. This column here is telling you that it's the spinner on the left, which is this guy here, okay? These columns here are referring to the spinner on the right, okay? So let's just make sure we're clear there. So let's fill in with what we know. All right, well, the sum here of 1 plus 1 is 2. What is the sum of 1 plus 2? 3. What is the sum of 1 plus 3? 4. Now let's go to the bottom. What is the sum of 2 plus 1? 3. 2 plus 2, 4. 2 plus 3, 5. And again here, guys, I was just adding my numbers just like this to get those answers, okay? Now let's start down here at the bottom. What is the probability of spinning and landing on a sum of 2? Okay, well, if you look inside the box that I highlighted for you here in red, I only see 1, 2. Right here, out of how many total numbers? 1, 2, 3, 4, 5, 6. So that probability here would be 2 over 6. Well, how about 1 over 6, guys, since there's only 1, 2. My fault. There we go. Okay, what about the sum of a 3? How many 3s do you see in the table? 2. So that would be 2 over 6, which will reduce. This is divisible by 2. So this turns into 1/6 as well. Okay, third one, probability of getting a sum of 4. How many 4s do we see? 2. So that would again would be 2 over 6, which reduces down to 1 over 6. And the probability of getting a sum of 5, well, I only see 1 5 in the table. So that's 1 out of 6 as well. Okay, this one is kind of tough, but I do like it. So let's try to work through it together. It says an arts and crafts store has a crate that contains glass, wood, and brass beads. Friends take turns choosing beads. Without looking, they record the type of bead and then they return it back to the crate. The table shows the results of 300 selections. Write a probability model for choosing a bead. Okay, remember your probability model consists of 2 things. That's the sample space and then the probabilities of those events within that sample space. So let's take a moment and write out our sample space. Alrighty, so I listed your sample space for you, which was glass, wood, and brass. I found the probability of the glass by looking at my chart. I noticed there were 60 pieces, so there 60 went on top. Out of how many total beads? 300. So that's what I did for each. Now, I did reduce my fractions. I'm pretty sure you will not have large numbers like this on tests, so don't freak out. If you can at least get me the probability here, you're going to be doing just fine. Now let's move to B. Based on the frequencies, don't forget, frequencies are a fraction, okay, or numbers that you're going to make a fraction. Based on the frequencies in the table, estimate the number of each type of bead that will be chosen if friends select a total of 450 beads from the crate. All right, well, we're doing something more than once, therefore we will need 2 fractions, and we're going to need to do that for glass. I'm going to use the G. We'll need to do it for the wood and also the brass. So So first you're going to need the Glass's theoretical probability, which we found at the top up here to be 1/5 when reduced. So 1/5 equals x over 450, and you will need to butterfly. For the wood, it would be our reduced probability from part A, which is 8 over 25. So 8 over 25 equals x over 450. And same thing for your brass. 12 over 25, and again, that came from part A, equals x over 450. All right, I want to give you guys a moment. I want you to butterfly these and make sure you are coming out with the correct answer that I get. So go ahead and pause your screen. Don't forget, multiply your partners, divide that by 5. Multiply your partners, divide by 25. Multiply your partners, divide by 25. Pause the screen, try it on your own. All right, how did you do? Hopefully you got it. Good job, guys. Okay, number 10, a bag contains 14 green, 12 orange, 19 purple tennis balls. Part A, create a probability model for choosing a tennis ball. All right, probability model consists of your sample space and their probabilities of each event. I want you guys to pause this screen. I want you to try A, and I want you to try B. Now remember, you're doing something more than once on part B, okay? So make sure you understand you'll need 2 fractions. Pause the screen, give it a try. All right, let's see how you did. Hopefully some of you got this right. Let's move on. Number 11, given the probability that a red pepper is 3/5. Write another probability statement to complete the probability model of a random pepper selected from the box below. Okay, well, since they gave us the probability of red, let's give them the probability of yellow. All right, pause the screen, count those yellows up for me. I counted 6 out of how many total peppers? 15. Now this fraction will reduce. It is divisible by 3. 3 goes into 16. 2 times 3 goes into 15. 5 times. So final answer, 2/5. All right, guys, I'm going to let you skip 12. So you can go ahead and write this. We may come back to it later. And I'm going to let you skip 13. Let's go ahead and call it a day. I want you to go on now to your quick check, which is right under the lesson you're watching right now. Try your quick check. Let's see how you do. If you need to talk to a friend or a partner to get yourself some help, you may. And if you need to use your notes, you may. Make sure you're getting your homework done, guys. You don't know how important it is for this lesson. Once you're done with your quick check, I'm going to put a booklet up so you guys can practice with your probability. Hope you understood your lesson, and I hope all of you have a great day.